Robert A. Millikan was an American experimental physicist honored with the Nobel Prize for Physics in 1923 for his measurement of the elementary electronic charge and for his work on the photoelectric effect. Millikan graduated from Oberlin College in 1891 and obtained his doctorate at Columbia University in 1895. In 1896 he became an assistant at the University of Chicago, where he became a full professor in 1910. In 1909 Millikan began a series of experiments to determine the electric charge carried by a single electron. He began by measuring the course of charged water droplets in an electric field. The results suggested that the charge on the droplets is a multiple of the elementary electric charge. But the experiment was not accurate enough to be convincing. He obtained more precise results in 1910 with his famous oil drop experiment in which he replaced water with oil. In 1914 Millikan took up with similar skill the experimental verification of the equation introduced by Albert Einstein in 1905 to describe the photoelectric effect. He used this same research to obtain an accurate value of Planck's constant. In 1921 Millikan left the University of Chicago to become director of the Norman Bridge Laboratory of Physics at the California Institute of Technology in Pasadena, California. There he undertook a major study of the radiation that the physicist Victor Hess had detected coming from outer space. Millikan proved that this radiation is indeed of extraterrestrial origin, and he named it cosmic rays. As chairman of the Executive Council of Caltech from 1921 until his retirement in 1945, Millikan helped to turn the school into one of the leading research institutions in the United States. He also served on the Board of Trustees for Science Service, now known as Society for Science and the Public, from 1921 to 1953. Biography. Education. Robert Andrews Millikan was born on March 22, 1868, in Morrison, Illinois. Millikan went to high school in Maquoketa, Iowa. Millikan received a bachelor's degree in the classics from Oberlin College in 1891 and his doctorate in physics from Columbia University in 1895. He was the first to earn a Ph.D. from that department. At the close of my sophomore year, my Greek professor asked me to teach the course in elementary physics in the preparatory department. During the next year, to my reply that I did not know any physics at all, his answer was, "Anyone who can do well in my Greek can teach physics." "All right," said I, "you will have to take the consequences, but I will try and see what I can do with it." I at once purchased an Avery's Elements of Physics, and spent the greater part of my summer vacation of 1889 at home, trying to master the subject. I doubt if I have ever taught better in my life than in my first course in physics in 1889. I was so intensely interested in keeping my knowledge ahead of that of the class that they may have caught some of my own interest and enthusiasm. Millikan's enthusiasm for education continued throughout his career, and he was the co-author of a popular and influential series of introductory textbooks, which were ahead of their time in many ways. Compared to other books of the time, they treated the subject more in the way in which it was thought about by physicists. They also included many homework problems that asked conceptual questions, rather than simply requiring the student to plug numbers into a formula. In 1902 he married Greta Irvin Blanchard. They had 3 sons: Clark Blanchard, Glenn Allen, and Max Franklin. Charge of the electron. Starting in 1908, while a professor at the University of Chicago, Millikan worked on an oil drop experiment in which he measured the charge on a single electron. J.J. Thomson had already discovered the charge-to-mass ratio of the electron. However, the actual charge and mass values were unknown. Therefore, if one of these two values were to be discovered, the other could easily be calculated. Millikan and his then graduate student Harvey Fletcher used the oil drop experiment to measure the charge of the electron. Professor Millikan took sole credit, in return for Harvey Fletcher claiming full authorship on a related result for his dissertation. Millikan went on to win the 1923 Nobel Prize for Physics, in part for this work, and Fletcher kept the agreement a secret until his death. After a publication on his first results in 1910, contradictory observations by Felix Ehrenhaft started a controversy between the two physicists. After improving his setup, Millikan published his seminal study in 1913. The elementary charge is one of the fundamental physical constants, and accurate knowledge of its value is of great importance. His experiment measured the force on tiny, charged droplets of oil suspended against gravity between two metal electrodes. Knowing the electric field, the charge on the droplet could be determined. Repeating the experiment for many droplets, Millikan showed that the results could be explained as integer multiples of a common value, the charge on a single electron. That this is somewhat lower than the modern value of 1.602 by 10⁻19 km is probably due to Millikan's use of an inaccurate value for the viscosity of air. Although at the time of Millikan's oil drop experiments it was becoming clear that there exist such things as subatomic particles, not everyone was convinced. Experimenting with cathode rays in 1897, J.J. Thomson had discovered negatively charged corpuscles, as he called them, with a charge-to-mass ratio 1840 times that of a hydrogen ion. Similar results had been found by George Fitzgerald and Walter Kaufmann. Most of what was then known about electricity and magnetism, however, could be explained on the basis that charge is a continuous variable, in much the same way that many of the properties of light can be explained by treating it as a continuous wave rather than as a stream of photons. The beauty of the oil drop experiment is that, as well as allowing quite accurate determination of the fundamental unit of charge, Millikan's apparatus also provided a hands-on demonstration that charge is actually quantized. The General Electric Company's Charles Steinmetz, who had previously thought that charge is a continuous variable, became convinced otherwise after working with Millikan's apparatus. Data selection controversy. There is some controversy over selectivity in Millikan's use of results from his second experiment measuring the electron charge. This has been discussed by Alan Franklin, a former high-energy experimentalist and current philosopher of science at the University of Colorado. Franklin contends that Millikan's exclusions of data do not affect the final value of the charge obtained, but that Millikan's substantial cosmetic surgery reduced the statistical error. This enabled Millikan to give the charge of the electron to better than 0.1%. In fact, if Millikan had included all of the data he discarded, the error would have been within 2%. While this would still have resulted in Millikan's having measured the charge of E- better than anyone else at the time, the slightly larger uncertainty might have allowed more disagreement with his results within the physics community, which Millikan likely tried to avoid. David Goodstein argues that Millikan's statement, that all drops observed over a 60-day period were used in the paper, was clarified in a subsequent sentence which specified all drops upon which complete series of observations were made. Goodstein attests that this is indeed the case and notes that 5 pages of tables separate the two sentences. Photoelectric effect. When Einstein published his seminal 1905 paper on the particle theory of light, Millikan was convinced that it had to be wrong, because of the vast body of evidence that had already shown that light was a wave. He undertook a decade-long experimental program to test Einstein's theory, which required building what he described as a machine shop in vacuo, in order to prepare the very clean metal surface of the photoelectrode. His results, published in 1914, confirmed Einstein's predictions in every detail, but Millikan was not convinced of Einstein's interpretation, and as late as 1916 he wrote Einstein's photoelectric equation. cannot in my judgment be looked upon at present as resting upon any sort of a satisfactory theoretical foundation, even though it actually represents very accurately the behavior of the photoelectric effect. In his 1950 autobiography, however, he simply declared that his work scarcely permits of any other interpretation than that which Einstein had originally suggested, namely that of the semicorpuscular or photon theory of light itself. Since Millikan's work formed some of the basis for modern particle physics, it is ironic that he was rather conservative in his opinions about 20th-century developments in physics, as in the case of the photon theory. Another example is that his textbook, as late as the 1927 version, unambiguously states the existence of the ether, and mentions Einstein's theory of relativity only in a non-committal note at the end of the caption under Einstein's portrait, stating as the last in a list of accomplishments that he was author of the special theory of relativity in 1905 and of the general theory of relativity in 1914, both of which have had great success in explaining otherwise unexplained phenomena and in predicting new ones. Millikan is also credited with measuring the value of Planck's constant by using photoelectric emission graphs of various metals. Later life in 1917, solar astronomer George Ellery Hale convinced Millikan to begin spending several months each year at the Throop College of Technology, a small academic institution in Pasadena, California that Hale wished to transform into a major center for scientific research and education. A few years later, Throop College became the California Institute of Technology, and Millikan left the University of Chicago in order to become Caltech's chairman of the Executive Council. Millikan would serve in that position from 1921 to 1945. At Caltech, most of his scientific research focused on the study of cosmic rays. In the 1930s, he entered into a debate with Arthur Compton over whether cosmic rays were composed of high-energy photons or charged particles. Millikan thought his cosmic ray photons were the birth cries of new atoms continually being created to counteract entropy and prevent the heat death of the universe. Compton would eventually be proven right by the observation that cosmic rays are deflected by the Earth's magnetic field. Robert Millikan was vice chairman of the National Research Council during World War I. During that time, he helped to develop anti-submarine and meteorological devices. He received the Chinese Order of Jade. In his private life, Millikan was an enthusiastic tennis player. He was married and had 3 sons, the eldest of whom, Clark B. Millikan, became a prominent aerodynamic engineer. Another son, Glenn, also a physicist, married the daughter of George Lee Mallory of Because It's There Mount Everest fame. Glenn was killed in a climbing accident in Cumberland Mountains in 1947, a religious man and the son of a minister. In his later life, Millikan argued strongly for a complementary relationship between Christian faith and science. He dealt with this in his Terry Lectures at Yale in 1926-7, published his Evolution in Science and Religion. A more controversial belief of his was eugenics. This led to his association with the Human Betterment Foundation and his praising of San Moreno, California for being the westernmost outpost of Nordic civilization, with a population which is twice as Anglo-Saxon as that existing in New York, Chicago or any of the great cities of this country. Westinghouse time capsule in 1938. He wrote a short passage to be placed in the Westinghouse time capsules. At this moment, August 22, 1938, the principles of representative ballot government, such as are represented by the governments of the Anglo-Saxon, French, and Scandinavian countries, are in deadly conflict with the principles of despotism, which up to 2 centuries ago had controlled the destiny of man throughout practically the whole of recorded history. If the rational, scientific, progressive principles win out in this struggle, there is a possibility of a warless, golden age ahead for mankind. If the reactionary principles of despotism triumph now and in the future history of mankind will repeat the sad story of war and oppression as in the past. Death and legacy. Millikan died of a heart attack at his home in San Moreno, California in 1953 at age 85, and was interred in the Court of Honor at Forest Lawn Memorial Park Cemetery in Glendale, California. Millikan Middle School in the suburban Los Angeles neighborhood of Sherman Oaks is named in his honor, as is Robert A. Millikan High School in Long Beach, California. The Millikan Library, the tallest building on the Caltech campus, is also named after him. Additionally, a major street through the Tektronix campus in Portland, Oregon, is named after him, with the Millikan Way, a station on Portland, Oregon's Max Blue Line, named after the street. One of 4 suites at the Athenaeum Hotel on the Caltech campus is named after him, room number 50, the Millikan Suite. On January 26, 1982, he was honored by the United States Postal Service with a 37 Great American Series postage stamp. Famous statements: if Einstein's equation and Einstein's curve are even roughly correct, as I'm sure they are for Dr. Cameron and I have computed with their aid the maximum energy evolved in radioactive change and found it to check well with observation, then this supposition of an energy evolution through the disintegration of the common elements is from the one point of view a childish utopian dream, and from the other a foolish bugaboo. Bibliography. Goodstein, D. In Defense of Robert Andrews Millikan, Engineering and Science, 2000. Number 4, pp. 30-38. Millikan, R.A. The Autobiography of Robert Millikan. Millikan, Robert Andrews. The Electron, Its Isolation and Measurements and the Determination of Some of Its Properties. The University of Chicago Press. Nobel Lectures, Robert A. Millikan, Nobel Biography. Elsevier Publishing Company, Amsterdam. Siegerstrail, You Good to the Last Drop. Millikan Stories as Canned Pedagogy, Science and Engineering Ethics Volume 1, pp. 197-214. Robert Andrews Millikan, Robert A. Millikan, Nobel Biography. The NIST Reference on Constants, Units, and Uncertainty. Kevlas, Daniel A. Robert A. Millikan. Scientific American 240, 142-151. DOI 10.1038, Scientific American 0179-142. Kagan, Robert H. The Conservative Mode. Robert A. Millikan and the 20th Century Revolution in Physics. ISIS 68, 509-526. DOI 10.1086, 351,871. JSTOR 230006.